In 11.3, we're going to find probabilities using combinations. And combinations are kind of a similar idea to the permutations, but we're going to talk about what makes them different in a minute. So learning objectives are using a formula to calculate combinations, and our key vocabulary for this section is what is a combination. And when you think about permutations, it was important that the order of the arrangement of objects mattered. So we used examples of putting the tracks onto a CD, or in what order were different floats going to be arranged moving through a parade. So order in that case mattered. In combinations, order does not matter. So what's important here is that the combination is an arrangement of objects in which order is not important. Okay, in permutations it is important, in combinations it's not. So for example, if I talked about that CD example from the previous, I've got 12 songs, and I just want to decide 9 of the 12 songs to be on the disc, but I don't care what order they're in, then that would be combinations. What we calculated was how many different ways can I put those 9 tracks in order on the disc, so order mattered. So for instance, if we are drawing for 3 identical prizes, I'd use combinations because there's no difference between winning the first prize or the second prize or the third prize. If the prizes are different, then we'd use permutations because order would matter. So when we talk about counting combinations, combinations of 2 letters, so I could have AB, AC, AD, right? I can have BA, BC, BD. I can have CA, CB, CD, and I could have DA, DB, and DC. But this is permutations. But if you look at, I have AB and BA, these are the same. I have AC and CA. I have AD and DA. They're the same combination. So I have BC and I have CB, that's redundant. I have BD and I have DB, that's redundant. Okay, and here I have CD and I also have DC, that's redundant. So in terms of permutations, you can see that there are 12, but in terms of combinations, there are only 6. Okay, so when you order doesn't matter, CD and DC are the same thing. Okay, and so we have a different formula. It's very similar to the other formula for permutations. And you notice this n factorial over n minus r factorial, that's the same. But then we have this extra times r factorial in the denominator, which makes it smaller. There are always less combinations than permutations. And of course, because we're talking about combinations, we use the capital C. Okay, so this is the way we would go about calculating it. 4 factorial over 4 minus 2 factorial times 2 factorial. Remember, 2 factorial times 2 factorial is not 4 factorial. They're very different. So then we start canceling common factors and we end up with 6, which was what I just showed you. Okay, so if we wanted to see how we use this in action, I want to order a sandwich at a restaurant and I can choose 2 side dishes from a list of 8. So remember, if I'm choosing potato salad and coleslaw, it doesn't matter if it's coleslaw and potato salad or potato salad and coleslaw. They're the same pair of side dishes and my meal is the same. Okay, so to calculate this, we'll have 8 factorial. I'm sorry, remember that it's combinations of n items taken r at a time is n factorial over n minus r factorial times r factorial. So then I'll have 8 minus 2 factorial times 2 factorial. So this is 8 factorial over 6 factorial times 2 factorial. And if I break down 8 factorial, it's 8 times 7 times 6 factorial. So you see I'm only factoring it down and writing the factorial out until I get to match the largest factorial in the denominator, because these are going to cancel. 2 times 1 is 2. 2 goes into 8 4 times. 4 times 7 is 28. That's how many different combinations of side dishes I could choose, picking 2 at a time from a set of 8. Okay, if we want to discuss this a little further, so in this example, a yearbook editor has selected 14 photos, including one of me and one of my friend, to use in a collage for the yearbook. The photos are placed at random, and there's room for 2 photos at the top of the page. What's the probability that your photo and my friend's photo are the 2 placed at the top of the page? Okay, so the first thing I want to know is how many possible outcomes are there? So that's how many different sets of 2 photos can I pick from a set of 14? So that's going to be 14 factorial over 14 minus 2, which is 12 factorial, times 2 factorial. So that's going to be 14 times 13 times 12 factorial. 2 factorial is 2 times 1. 12 factorial cancels with the other 12 factorial. 2 goes into 14 7 times, so 7 times 13, there are 91 different ways for that to come about. Now the number of favorable outcomes, that's me and my friend being in the top 2. There's only one combination that's me and my friend, so it's 1 out of 91. Okay, that's the probability. So a little more than 1%. Okay, and that's working with calculating probabilities based on combinations. Remember, the key thing about combinations is that the order is not important.